morning. So today I'll be talking about how we build high-quality node services at Uber. A bit about me. I'm Reynos on the internet. I work for Uber on the real-time team, and I spent the last couple of months figuring out how to make it easier to deploy new services at Uber. You guys have already heard lots of microservices talks. At Uber, we had a couple of monoliths in the past, and we're now working on making it easier to spin up new, smaller services, especially in Node. We already had a great story for building up new services in Python, but not so much for Node. So a bit of background on what happened when I joined the company. I joined the company about 9 months ago. And on the first day, I underwent what I call the Iron Fist trial. So one of my coworkers gave me a nice small piece of work to do to break me in. It was just building a proxy for statsd to add some filtering and normalizations. We are sending nulls and undefineds as strings to the statsd server, and the statsd guys weren't happy with that. So I spent a day building it out, just write a Node app, really easy, writing Node microservices in the HUD. And then my coworker showed me how we, test it out. So how do we test it? You SSH into a production box, clone it, run it, change the config from one of the production services to point at it, just restart it. Okay, it works, cool. You've written some code on your first day, you've got it kind of working in production on one machine. And then the next step is simple. You just deploy it to all 50 machines. And since it's a statsd proxy, it should just never go down because our stats are really important for insight. And then my coworker just said, spend a couple of days productionizing it and making sure that we can deploy it to 50 machines. So that would have been pretty easy if I checked the code into our existing monolith. But writing a new service and running it on lots of machines and making sure it's solid and doesn't go down and having good insight in it, that's something I found really hard. And that's something where I spent a lot of time figuring out how to do that at Uber. So there's multiple steps to keeping insight into production services. And one of the first things I broke out of our monolith is the way we did logging. So logging is a pretty standard affair. You want to log info messages, warnings, and errors. The warnings are there to be able to see what's going on with your process. If you think there's something going wrong with your process, you want to be able to just SSH into the box, look at the log files, and take a look at the warnings and see, maybe I can tell what's going on. We also pump out all of the logs for all your services to a distributed queue. Internally at Uber, we use Kafka, but we could have used anything. The advantage here is if we deploy our service to, say we have a service running on 20 servers, and we just do a global deploy, which we do twice a week, we want to be able to just read from the queue and grab it for error messages right after the deploy. If we see any errors right after the deploy, we know something went wrong, and we want to be able to just quickly roll back. We also send all our errors to any error reporting service of your choice. We internally use Sentry. It's worked quite well for us. What we do with Sentry is we have a very healthy attitude around anything that goes into Sentry as a bug, and it has to be fixed. We wrote a little custom server to do git blame on Sentry bugs that come in. So if we see a new Sentry bug, we take a look at the recent deploys, take a look at the recent git commits, and we try and point at the correct developer and send them an email and say, hey, fix this, make this go away. So for the little statsd service I wrote, I added some logging, I added some little info warnings and errors about what's going on so that I can see that stuff. But the logging is only really useful when I'm paying attention to it in real time. I also needed insight over a long period of time on what was happening in my application. At Uber, we have a very healthy attitude towards monitoring. So we use the Linux client for doing stats-d stuff, and we monitor everything. Most of the time, when we write warnings to the logger saying like, hey, something weird happened, but it's not a bug, but like somebody should be aware of this, we also send that stuff to stats-d. We then configure the stats-d graph so that if we see a spike of warnings, or we see the warnings hit a threshold that's like a certain amount per hour, we get emails about it, we get notifications about it. We monitor all the traffic going through, all the standard stuff you want to see on every service. And the nice thing about monitoring the traffic is we set it up so it comes for free with every service. We have a little wrapper around a HTTP server that monitors all the requests, all the volume of 400s, 500s, anything you want to see. And then obviously, when you're doing monitoring, you're supposed to monitor your actual business logic. You're supposed to monitor the core parts of your application. For Uber, we have drivers and we have clients on the Uber app. So we monitor the volume of drivers and clients per city. And again, when we see any kind of changes in that, we need to know immediately, and we need to be told about that. The next step in getting the service running in production scale is configuration and managing configuration. So managing configuration, you can do it in lots of ways. We have a module for it. One of the approaches we have that we really like is that configuration is a bunch of JSON files local to the process checked into Git. I've tried multiple times to have shared configuration files as submodules or as NPM dependencies, and that is always more painful than you want it to be. Updating those dependencies is horrible. We deal with command line overrides. Whenever you're dealing with configuration, you want a way of having configuration local to your application, but you also want to take in configuration from the outside. So our infrastructure team really likes to tell us what port we should be running on, because we shouldn't be picking our own ports. We need to support multiple data centers out of the box. When running in multiple data centers, the way everything is configured is different. Especially when you're spinning up a new data center, half of the services you're depending on probably not running on a data center, so you want to configure your application to, point your hosts and arrays to the old data center. And we have a way of doing remote overrides. One of the really nice features we have internally is just being able to tell a process like, hey, change your configuration without restarting. We have a whole dashboard for changing configuration, which is really useful for turning features on and off on the fly, or dealing with A/B tests, or even just tweaking, fine-tuning your application. We've had to fine-tune timeouts so many times on an application. A lot of the way we do production at Node is for every single external HTTP dependency, we configure the timeouts so that if an external service takes too long, we bail early and don't hold up the process. And that kind of stuff always needs tweaking. If you see another service is hitting load, maybe you just want to tweak the timeouts to keep your system running smoothly. Another step in productionizing a service is dealing with uncalled exceptions. So you wrote a module at Uber for dealing with uncalled exceptions, and there's really 3 steps to it. You need to get the uncalled exception out of the process, so probably integrate with your logger of choice, but also don't depend on the logger being in a good state when you have an uncalled exception. We've had plenty of cases where we don't have any insight in the uncalled exception, spend a couple hours debugging it, and then realizing it was a bug in the logger itself. So one of the things we do is we literally pipe it out to standard out or to a file descriptor as well. You then want to do a graceful shutdown. At Uber, we don't believe in continuing on uncalled exceptions. We've tried that a bunch of times, and it's really not worth it. And eventually, you want to abort the process, and maybe dump call, maybe not, depends on how your system's configured. The next step that's really useful for our services, and every service, no service we build, has a control port in it. Now, a control port is just a way of asking a process to do things that is useful for the developer. The things we ship with by default are a profiler and a way to do heap dumps. We've had plenty of occasions where we see a process acting bad with memory, and then realizing we haven't imported the heap dump module into the process and we can't actually take heap dumps. So by having a control port by default in every single application you build, you know what will be there when you need it. And the last step to productionizing a service is integrating with whatever you use to be notified of failures. So we use PagerDuty and Nagios internally, and if something goes down, you need to wake up. That's just how it works. Like if you build a service, you're now responsible for it, and you're gonna go on PagerDuty 24/7. You wake up, you fix it within 10 minutes. If it's not fixed within 10 minutes, you wake up one of your managers. So how do we do that kind of stuff? We have health checks in every process. If the health check fails, Nagios will tell us, Nagios will tell PagerDuty. The way we do health checks is it's not just an endpoint that you get to and it returns to 200. It's an endpoint you get to, and it checks whether this local Redis connection is healthy. It checks whether its other local dependencies are healthy. We have integrated our dashboards and our monitoring in Graphite quite closely with Nagios. And we basically get Nagios alerts and phone calls if anything spikes in our dashboards. That's important. So step one to making it easy to productionize something is to have a whole bunch of modules that you can just import and be like, I don't have to care about this anymore. This is no longer my problem, and I'll ship with them by default. The second step is just making it easy to get started. It used to take a whole bunch of effort to get a new Node app from nothing to deployed in one day. We've tried to remove every layer of annoyance with automation. We wrote a CLI tool called Potter. And it's basically supposed to work you through a staged workflow of what does it actually take to get a production app running and deployed. So the first workflow is the local workflow. When you run the Potter command, and I'll give a demo in a second, it will check for conflicts on names or anything else. Mostly names. You'll be surprised how many people try to create a thing with the same name internally. It will scaffold out all the boring files you need. It creates you a local Git repository, so you can actually start working on stuff. And then it will make sure your tests pass locally. So it runs npm install, gets all your dependencies in. Our default scaffolds all come with 100% code coverage requirements, and they all come with enough tests to get 100% code coverage. So the moment you run this tool, that's it. You can now start coding, and you can start running tests, and you can start working. But there are more things necessary to do when building an application than just your local concerns. If you want to build an application in a team with multiple people, you need to care about shared concerns. Concerns you need to have when working with people. You need to push it to GitHub or GitLite or whatever Git or not Git server you run internally. You need to set up the proper documentation and wiki pages in whatever your system you have for that internally. And I hope, for the love of God, that somebody has set up Jenkins once and nobody else ever has to do that. Whether that's Jenkins or Travis. Travis is a bit easier to set up than Jenkins. You want a tool that deals with that for you and just make sure that you can hit a couple of buttons and then you can start making pull requests. Or in our case, we use Facebook's Arcanist tool internally. I don't know who made that call, but we also have integration with Arcanist so that whenever you make a new pull request or diff or whatever, we start a build, we start the CI going. Okay, so that's enough to work with other people. Because whenever people want to do code review, and we have a healthy attitude of 2 code reviews per pull request internally at Uber, they want to be able to see the build and they want to see what a Jenkins runs. We used to have a wild west of like, you're lucky if you have a Jenkins build, especially for libraries. We had lots of internal libraries without any kind of CI setup. The next step is EC2. So the way we do development is everybody, well, the way we're supposed to do development is not to work on your machine, but to work on EC2. And the point of that is to run something that looks as close to production as possible on a remote machine somewhere. So we want to make it really easy to like build a new, scaffold out a new app, and actually get it running in EC2. Which means we have to integrate with our internal Puppet God repository, which is, it was fun to learn Puppet. Hopefully nobody else would ever have to learn that. I'm sure everybody else has different systems for how they try to like reproduce their entire system in staging, but you want to find a way to make that painless. You want to find a way of just being able to slot a new application into your staging system as part of your developer workflow, so that your developer who's working on building a new app can just go and refresh his own staging server, and then it's running on the port it's supposed to be running, and he can curl it, and he can deploy a new version to it. And then the last step is production, like what is necessary to get something deployed to production. So because our EC2 and production systems are so similar, the only real difference is how many servers are you running on, what are those servers, and maybe if the service is special, you need to allocate a whole bunch of databases or anything else weird. But you also have to do stuff you forget about. Like somebody has to go and set up Sentry for you. Somebody has to go and add your project to PagerDuty. Somebody has to go and generate dashboards in Graphite. Because if you don't make it easy to create dashboards and monitoring tools in Graphite for developers, nobody else will. Like nobody else bothers to like think, I should have a dashboard. We need to ship with that so that people can have the insight when they need it. Because if it's not there already before they need it, people are flying blind. And we have a custom deployment system when we integrate with it, and it does all kinds of magic for our special use cases. But at the end of the day, it means that once you're done with running the Potter tool, and once somebody else has said, okay, it's actually okay to put your service in production, you can actually deploy it somewhere. And you can deploy it, and you can wait for someone to allocate a DNS record. And once that's happened, like you're done. You don't have to think about anything else anymore. The way we wrote it is pretty modular, and you can write your own stuff. Writing your own stuff is pretty boring. But the important thing about being able to write your own stuff is when you write a tool like this that automates how you should build applications and how things should work, you really need to empower your teams in your company to be able to customize it. So we have a real-time team at Uber that like builds backend services with no front ends, no nothing. We care about different things from the web team. The web team customize our tools, use most of our code, but like add front-end stuff, add asset managing stuff, add uploading your assets to a CDN as part of like the staging process. And I'll give a quick demo of this. Come on, line tool. For some reason, it was previously called Play-Doh. So we have a Potter create command. And the way we deal with, I can't do anything. The way we deal with conflicts is if there's multiple ways of creating an app, we prompt the user to pick one. So I want to create a GitHub workflow. And I want to pick a name for a project. So I'm going to pick the Hello World, because that's a great name. And then it's supposed to do something. It's incredibly useful to actually prompt everybody to enter a description for their services, because we get an email for every single service getting created. And without descriptions, we know nothing, because people pick the worst names. If you give people the ability to pick a name, they will pick the worst names. So as part of automating things, you get to points where it actually isn't possible to automate something. So if you take a look at what the prompt did, it prompted you to be like, hey, you need to set up coveralls. And coveralls doesn't have a public API, so I'm just going to tell you to go in there and like press some buttons. And I'll skip this because it's really not interesting. And then I need to tell the tool, like, yes, I did do that. And it will go and create everything and push code, and I can go and cd into the app, and npm test works, and coverage is 100%. No, it's not 100%. Whatever, it's close enough. And if I go to GitHub, hello world, by the time you're done running this tool, you really should be set up to do everything you want to do. You really should have Jenkins running, or Travis, whatever your CI system is. You just want to make it really easy to just, I need to create a new thing, let me just create a new thing, and get started and not have to think about anything else. And the slideshows are here. Thank you.